Hello and welcome to everybody who is on the line and just joined this webinar. We will go ahead, by my clock, we have 1 minute till right now. I'm going to give it another couple minutes for people to join in and then we'll get started. So thank you for joining. Looks like we have some more people trickling in here. We'll get started in just a minute. Welcome to those who just logged on. We'll get started in about 1 more minute. All right, well, I have 1 minute after by my my clock on my computer here, so I think we will go ahead and get started. So hello, and thanks for joining us today. I'm really excited to continue this newest installment in the Macmillan Teaching Topics webinar series with this discussion about CURES, course-based undergraduate research experiences. So my name is Will Moore, and I work as part of the Life Sciences product team here at Macmillan. We're so happy to have the chance to engage the STEM community with this series of teaching webinars, so thanks for taking the time to join us. Our speakers today are Erin Dolan and Gabriela Weaver. Erin's a professor of biochemistry and molecular biology at the University of Georgia. Gabriela serves as special assistant to the provost for educational initiatives at the University of Massachusetts Amherst. So they're both heavily involved in the CURES community and are the authors of a new publication by Macmillan as part of our scientific teaching series, which is titled A Guide to Course-Based Undergraduate Research. So before we get started, I just wanted to add a few logistical details. Because we have a large audience on the line for this webinar, so voice communications are muted by default. We really want this to be interactive, so I'd encourage all of you to submit any questions or comments you may have using the question functionality and the sidebar controls of GoToWebinar. I'll be monitoring those throughout the presentation, so whenever you have something pop into your head, please ask it there. And I will moderate that when it gets time for questions toward the end. So I'm really thrilled to have our speakers here today to talk to you guys about this topic. So with that, I'm going to pass it along to them to go ahead and get started.
Great, thanks so much, Will. And thanks to Macmillan for hosting and to you all for joining us. So as Will said, I'm Erin Dolan at the University of Georgia. We're here to talk with you about course-based undergraduate research experiences. And I'll get us started and then hand things over to Gabriela. So, oh, see, already technology issues. So some of you may be aware, or a lot of you may already be aware, there's large calls across the country for involving undergraduates in research. This is apparent in large-scale policy documents like the President's Council on Science and Technology, in Vision and Change if you're in the life sciences, that research experiences should be an integral part, especially in the STEM disciplines and in life sciences in particular. There's been a real move to involve undergraduates in research. And in fact, AAC&U, a leading organization connecting colleges and universities in the US, has identified undergraduate research as one of the 10 high impact educational practices. And the reasons behind this are manyfold. So we know from lots of research over many years from many folks that students benefit from participating in research internships. So they make gains in knowledge and skills, both specific to their discipline and their project, but in general about what science is and how science is done. They make gains in terms of attitudes and dispositions. So for example, they may not necessarily be interested in growing up to be a researcher, but they may develop more positive attitudes towards researchers and more positive dispositions toward research endeavors. They also develop identity and connections within the research community. So for example, they might begin to identify as a researcher themselves, and this might then influence their career pursuits, and they also develop connections that they wouldn't otherwise make with faculty in classrooms that shape their education and career trajectories. So lots of potential benefits that students can realize from participating in research. So this then raises the question about how students get access to research experiences and who is able to access these research experiences. And what I want you to do now is just consider briefly to yourself, either if you did research as an undergrad, or if you work with undergraduate researchers or know other undergraduate researchers, how you got access to this experience, or how you identify undergraduates to do research with you. When I ask this question in seminars with grad students, postdocs, faculty, lots of different researchers, inevitably they point out a couple of big ideas that really influence whether students get into research experiences or have access to these experiences. And these big ideas fit with Boureaus' theory of capital. So if you think of undergraduate research as a form of capital, so not money, but rather a limited resource that people can get access to. People get access to this limited resource in three main ways: human capital, cultural capital, and social capital. So human capital is really the what you know. So students, for example, who've completed advanced coursework, or maybe even taken more challenging math and science courses as high school students, who've earned high grades, who have high test scores, or maybe they did research as a high school student, are the kinds of students who are going to come to college and be able to access research experiences as undergraduates more easily. There's also cultural capital, or sort of the how you know, and this actually really describes my own personal experience. My dad was an engineering professor at the University of Washington for many years, and so it was always pretty normal for me to hang out with researchers in STEM disciplines. They just seemed like my dad's goofy friends, and so it wasn't scary for me to go up to a faculty member and say, hey, I'd like to do research with you. And this really manifested in my own self-efficacy, so I was confident that I had something to offer and that I was going to be capable. And knowing that research is a thing that I could do or should do, both in my education and in my career. And then finally, there's the who you know. And this is the special programs that students might be a part of that build research in. For example, the Lewis-Stokes Alliance for Minority Participation, if folks are familiar with that. Particular majors might require students to do research. My own biochemistry major here at University of Georgia, we require all students to do 2 semesters of research. And there also might be individuals who act as agents, connecting students with others who help them get access to research. So maybe I have a research program, but I don't have spots for a student right now, but I could connect a student with somebody else who could help them get access to a research experience who's looking for undergrads. And what we know is that students who have these 3 forms of capital are more likely to get access to research experiences and thus develop more human, cultural, and social capital. So this becomes a sort of positive feedback loop where if you get access to research, you gain more experience, you develop more capital, that gives you access to, again, new opportunities and resources that you wouldn't otherwise be able to access. So the challenge with this is that means that students who come to college primed for careers in research and primed for careers in STEM disciplines are the students who are most likely to persist and succeed in these disciplines. Their access to these experiences is based on their capital, and that means there's not enough for everyone. So I really got interested in course-based undergraduate research experiences for their potential to help a much broader group of students achieve these outcomes and to broaden access to research. And for the purposes that Gabriela and I have, we've been using this definition that we think is helpful to put forward at this time. Course-based undergraduate research experiences are experiences when the whole class of students, so all the students who are enrolled in a course, address one or more research questions or problems that are of interest to the broader community. So that means people outside the classroom, people outside the course are actually interested in the results of students' work and in the problems that students are working on. And now to get us into thinking about the key features of these experiences, I'm going to hand it over to Gabriela.
So Erin just laid out an important set of reasons why both she and I got involved in developing and implementing cures, and why many people are now thinking about and trying to use cures. So when we think about what they are, it's a little bit helpful to compare them to the more traditional research internships, which you might envision as the undergraduate doing summer or semester research in somebody's research lab, usually because they've approached somebody to get a position in their lab. In that situation, when you compare it to a cure, the scale is very different. So you will generally have one or just a few undergraduate students working with one researcher or one research lab, compared to a cure where you're going to have everybody who's in the course. So it's a one-to-many model in the cures versus the one-to-one type of model, or one-to-very-few in the standard undergraduate research experience. And the cures then would be open to whoever is allowed to take the course in which the cure is implemented. Much of the literature on cures actually involves the foundation level courses, so the big first year and second year courses. And that helps to achieve that goal of engaging a much broader audience of students in research. Those students who either didn't have the experience because they were first generation students, they didn't know that they're supposed to talk to a faculty member to get research experience. Maybe they've never heard about it. Maybe they simply didn't see themselves as somebody who could be a researcher. Those types of students then get this experience early on and can make decisions that they can then apply in the remainder of their college time. Whereas in a research internship, you have to have that social capital, right? That idea that you know it's a good idea to approach a faculty member to do research and get that position. So students may be self-selecting. Also, the faculty who are willing to work with students may have a certain selection process that ends up leaving many potential undergraduate researchers out of that URE loop. The setting is very different. It's the cures because they're intended to be done in a course-based undergraduate research. They're done in the traditional teaching labs. Now, those are spaces that are designed for more general purposes than the faculty research lab, which is usually optimized for one type of research activity, perhaps even one type of experiment that's being done. Also in the research, in the teaching laboratory, you're going to have a schedule to work around that is very different from what you would find in a faculty research lab. So that setting has both benefits and drawbacks with respect to how the cure needs to be structured. And then finally, the mentoring is going to be slightly different because in the cures, as part of a teaching experience, you're going to have specific people who are involved in mentoring the students, who are prepared to mentor the students at specific times, and there are going to be materials, and these are going to be the same for all the students involved in that cure. Whereas depending on what type of research involvement a student has with a particular faculty member, they may have very different mentoring experiences than somebody else, maybe even in the same institution, in their same department. Erin, let me just ask before I go forward, is there anything else you want to add about those similarities and differences?
No, that's great.
All right. So next slide. Now, we can think about the various reasons why we might want to implement and use cures as part of the educational experience for students. I'm going to lump these into three big buckets of reasons. Overarching reason one is that the students benefit. So cures can take a number of different forms. A few examples are given here. You can have an unstructured cure, a structured cure, a mini or starter cure, a cross-curricular cure. Now, an unstructured cure does not mean students go in and do anything they want. It means that the the model for that, for example, here's the Freshman Research Initiative is called out, the vertically integrated projects. That model is a framework within which faculty and students can work on a variety of different types of research questions, depending on the year, the faculty member, the specific sets of questions that they want to research. Whereas a structured cure is one in which the particular research question, research topic is set, and everybody across the country who is involved in those is contributing to that same research project. So examples of those are the Genomics Education Partnership and the Science Education Alliance out of Howard Hughes Medical Institute, phage hunters. Mini or starter cures are those in which students don't engage in a long-term cure experience, but get that experience of what it's like to do research, and in particular how that's different from the more traditional types of laboratory experiences that they might have in their courses. And it's intended to be a stepping stone to either undergraduate research experiences through the traditional form or to cures in upper division courses. And the cross-curricular cures are those in which you may have a cure that's depending on students to do something in their biology course, something in their chemistry course, something in another course, and bring them together. This might be at the same institution or may not. So you can have students at different institutions. That's not to say that one of the other types of cures couldn't also be a cross-curricular cure. In fact, many of them are. So these models are not mutually exclusive. Now, there have been a number of these cure projects that have been researched rigorously, and they have shown that students are retained in the major, they develop self-efficacy, they develop knowledge and skills, and abilities to communicate and work across diverse teams, a variety of other benefits as well. So the data on individual projects bear out some of the benefits, some of the specific benefits as well. Next. Now, in overarching reason bucket number 2, benefits to the faculty. So many faculty find themselves in a bit of a tug of war sometimes between their research activities and their teaching activities, and cures provide a natural bridge in which the research and the teaching are seamlessly integrated with each other. In fact, they inform each other directly. And as a result, many faculty who have been involved in cures report high levels of enjoyment and satisfaction in terms of teaching this way. They get to engage with students at a much deeper level with much more interesting to them questions and really help to guide the students in becoming scientists themselves. And so it's a very different dynamic for them. And plus they get to really explore aspects of their research that they might not get to otherwise. The next 2 bullets, promotion and tenure, publications, and research productivity, really sort of go hand in hand. When you develop an aspect of your research project to be carried out as a cure, there are going to be many hands and minds involved in the research. In fact, you may even explore aspects of that research question that you didn't have an opportunity to do when you are working with graduate students with a research lab where you're really looking at much bigger aspects of it. And so many questions can be explored at an early level by involving students in a cure, and that may contribute to publications, which of course can contribute to research productivity. Now, it's not the case that every time students are involved in a cure in the classroom that it necessarily leads to a publication directly. But it's very possible, and we've seen many examples of this. Examples exist in the literature, where the work that students do in the laboratory can accelerate publications out of the research lab because they have set the stage for some of those early questions or early directions that the researcher and their research group may be able to then pursue more deeply in their own research lab. Next. And finally, in big buckets of reasons, we have benefits to the research community. So I just mentioned different ways that the student engagement in the research can lead to publications. There are publications where you have hundreds, even thousands of names, and many of them are student names. There are other publications, like I mentioned, that have come out of the research lab, maybe with one or two of the students who decided to then continue to work on that project in the research lab. But there are other ways also that the work of students can contribute. For example, a research project may have a different group of stakeholders, such as in the community. Perhaps there is a research project that helps inform a group of community stakeholders about a community issue that they would like more information about. So there may be a report that goes to the community. There may be data or procedures that are published on the web, and that becomes a type of resource for the research community. So in the report that is referenced here on this slide, there are a variety of other different examples of ways in which the research of students can contribute to the research community. Next. So Erin and I decided to write a guidebook, and it seemed like a great idea when we started it. And in the middle of
a great idea.
It's still, no, it is. But in the middle of it, just like a great research project, we were like, oh my gosh, what have we done? But now it seems like a great idea again because it's finished and we're very happy with it. But it's useful to think about why we decided to do this. We didn't invent cures. Cures have been around for at least a couple of decades, if not more, especially if you look for projects that existed before the CURE acronym came to be popularized. So clearly people have been doing this, but Erin and I have both been involved in development of cures, implementation of cures, and then faculty development of others who are interested in engaging in cures. And through those years of process, what we've seen is that many people lack that initial first step. So they need something to just get them going. And that type of resource didn't really exist. So we decided that it would be useful to try to put some of that material together in a form that's easily accessible to faculty members and departments at a variety of stages, some who have used cures already, others who are thinking about it. Now, as I mentioned, Erin and I do have a couple of decades at least of experience with this. We have both been involved in faculty development of faculty, not only in the undergraduate arena, but also with high school teachers. And we've both been involved in undergraduate research for a long time. Erin has led the CureNet community of people and projects for many years, and I've led a couple of research institutes. We've both been involved in multi-institutional projects that involve cures. So we thought it would be a good idea to try to capture those experiences that we've got in a way that would be, like I said, accessible to people. The other benefit that we saw in working together is that Erin brings the life science perspective to this, and I'm a physical chemist, so I bring the chemical and physical perspective to it. And we tried to make this a guidebook that really speaks across disciplines, not specific to any one discipline. Erin, can you show us the table of contents?
Yeah, I'll add one other thing that it was a motivator for me, if it's all right. Gabriela, you set the stage really nicely, and I completely agree that this was an opportunity for us to hopefully make a useful resource for the community. I think the other thing that I'd like to call out is that Gabriela and I have both studied cures a fair bit and are really steeped in literature on learning and development, both for students and for faculty. And so we knew a lot of the research on how to help faculty think about course design and instruction and implementation of instruction and curriculum. And so we tried to build really good practices and principles related to teaching and learning into the design and content of the guidebook. not just our practical experience, but actually that research base in teaching and learning.
Right. Thanks for adding that. Good point. So the book is designed in such a way that you can certainly read it cover to cover and get a good understanding of what we have to share with you about cures, starting with why you'd want to do one all the way to how do you study them. But it's also, we tried to make it, in any case, a book that has multiple entry points. So depending on your level of experience with cures or what you want to find out about implementing cures, you can jump in and read one or two of the chapters, or jump in the middle and continue from there. For example, let's say you're somebody who's very experienced with implementing and teaching a cure, and now you'd like to do some scholarship. You go straight to chapter 6. If you're a department head and your faculty are interested in implementing cures and you'd like to know what that's going to mean on a practical level, then you can take a look at chapter 4 and get a sense of what the logistical aspects are. Institutionalization and scale up is for those who maybe have taught a course and now want to think about teaching more courses or having other faculty in the department or the college be involved in that. The first few chapters also provide a lot of that research background that Erin mentioned. Next. And in addition to the material in the main chapters, we added a great deal of material as appendices and online bonus material, but online resources to this. There are resources you can use for planning, for thinking about how you link your research goals and your student learning goals, actual instructional resources that help you get into that first day of class with your cure and make it a success. We included a section on contingency planning, following on the heels of our interesting year 2020. We realized that that's not the only time that instruction has been interrupted at an institution, and there are ways to deal with a variety of hiccups that might come around when you're implementing a cure. We've also provided worked full examples of cures, as well as templates that you can use for trying to implement your own cure. And with that, what we would like to do is really turn this into a conversation, as the title of the webinar implied, and take your questions and hopefully provide some insight, some further insight than what we've done through our PowerPoint presentation.
Great, thank you so much. I wanted to open it up to questions now. We already have some of these coming in that I'll get to in just a second. A few people asked about, is the book available now? It is. I just chatted a link out to the whole audience here, where you can find it for purchase on our website. If it's not showing on Amazon as being available yet, it should any day now. I know we've already shipped them from our warehouse out to them. So, okay, first question. So it's great information. What are your suggestions about implementing cures in a virtual environment? No surprise that that one was first question, right? Right to
the chance. Erin, you want to start?
Sure, absolutely. So I'm teaching a cure right now, but in the biology ed research space. So it's a little bit different, a little bit easier, because all of our research can be done using computers. But that might be a good place to start, is really think about what aspects of your research can be done using computational tools. And that doesn't mean students can't be involved in data collection or can't have their own little data chunk. In fact, you can think about data you have from your own research group, or there's even examples of orphan data sets or published data sets, for example, in the life sciences. One example I can think of is Dryad, is a data repository. And so I know students who've started to work on that. So it really depends on what your research is, but definitely using computational tools is a good way to go. And that can include using already collected data sets from your own research group. Gabriela, do you have ideas?
Yeah, another approach that I've seen tried. Now, I'm not currently teaching a cure, so I am speaking from what I have been reading about recently. I have heard of some folks that will actually have either a graduate student or one undergraduate in the lab videotaped while they're doing a procedure, and then collect data and make that data available. So students on the virtual side can be thinking about, in some cases, the research procedures. Then they can think about what they want to do with the data. In some ways, it's easier to get students to collaborate on data analysis together when you're in a virtual environment, so there's some benefits to it. But that's another way, if you absolutely have to do something that's in the lab, is potentially videotape it and share that out.
And we have several other examples of strategies in the book. For example, Gabriela led a cure initiative called CASPI, where there was actually remote functioning of research equipment, where students could collect and analyze data remotely. And I know other examples even of faculty doing the experiments in the lab and making intentional mistakes to challenge students to really think through issues that they might face. So maybe common errors that new researchers make in collecting data. So there's lots of ways that you can go about this. You just have to think creatively about what you want your students to learn. So do you care more that they learn about the data collection, more that they learn about the analysis, more that they're asking the questions, and then really thinking about how can you accomplish that? Can you be their hands? Can you give them data? What can you do that they can then work with?
Right, yeah, thanks for the reminder about the remote instrumentation. These days, a lot of instruments already come with the ability to be remotely managed and handled, and it's a matter of, like Erin said, is that the goal? Is that one of the things that is important to you for the students to learn? And to what extent can you protect your instruments from very inexperienced users handling them? But if you're able to do that, then that's a great way to ensure that students can still actually collect data and then do analysis remotely.
That's great, thank you. What are some of the challenges or barriers that what are some of the challenges, barriers that you know that can limit or preclude cures?
I can take a first stab at that, Erin. I'd say that when an author of a cure, I'll put it that way because they may or may not be the actual person who's doing the research if they're collaborating with somebody. When they begin to author it, the biggest challenge is thinking in a scale that fits in a teaching lab framework. So if you think about the teaching labs at your institutions, typically they meet 2, 3, maybe 4 hours a week, maybe twice a week, but often once a week. And there are only certain types of equipment that are going to be available for a large number of students. So thinking about how to take something that you've been accustomed to doing in a very specialized and optimized setting, now going into a more general setting, often is the first big hurdle. It is not impossible to overcome that hurdle. It's just a matter of rethinking how you chunk the research activities for students to do in those types of timeframes.
And I'll actually jump on, I'll sort of follow on that because I think one of the things that's really compelling, since we co-authored this book, it was great because I got to learn in more detail about Gabriela's experiences and the variety of cures she's worked with. But one of the things that I see sometimes faculty get in their own way because they feel obligated to solve all those problems for their students. Instead of saying, hey, we need a strategy to be able to do this technique that's not actually safe for you all to do. And so instead of going and solving that for them and finding an alternative technique, they say, your challenge for this week is to go review the literature, identify examples where the same kind of data has been collected in a variety of ways. And let's figure out a technique that actually might be suitable to do in a classroom at scale that's safe. And so putting that sort of intellectual effort back on them, and then you have many more minds solving the problem, right? You don't have to do it all. You can actually engage students in the process of doing what we as researchers do, which is work within the constraints of our own resources.
Great, thank you. What kind of resources or recommendations do you have for conducting cures in an anti-racist way? guessing this means maybe inclusivity. Those.
So
yeah, I feel like it's really more than that, but go ahead, Gabriela.
it may be more than that, but I want to go back to the beginning of the talk where Erin was talking about access. And I'm first generation to college and an immigrant, and I am very familiar with the situation of not having the social capital that I needed to access research, or to know that I needed to access research as an undergraduate. And as a faculty member later on, I was at Purdue when I started working on cures, which is an environment that's very large. The chemistry department in the first year course has thousands of students. And so it would be very easy for a student to simply get lost in the numbers, right, and never really get an in-depth experience. And that, my personal experience coupled with seeing that environment really made me want to ensure that there were experiences for students that they would get before they had solidified some identity or lack of identity. You know, I don't see myself as a scientist, or just didn't even know that that was something they could do. So this idea that that I have, that anybody can be a scientist if that's what they want to do. We just need to show them where the excitement of science lies, which may not be in the way that we've normally taught first year undergraduate labs. So that doesn't get at all of the question that the person is asking, that our viewer is asking, because I'm not talking about integrating specific anti-racist portions of the curriculum, but I am talking about trying to break down some of the barriers that have existed that have left out a number of different types of groups, such as those who are first generation, or those who have had experiences in high school before getting to college that didn't really prepare them for thinking about research. So Erin, do you want to add anything to that?
Yeah, I would just like to preface my comments. I think, Gabriela, that's lovely. Thank you for sharing, and especially sharing your own personal experience, because I think that that can really speak in a way that maybe I can't, as someone who came from a place of, you know, overeducated parents who were faculty. And I mean, I had a lot of privilege, and with over the past year, I've also realized I have very much to learn. So I am still very much in the learning space. I'm trying to understand, I'm trying to think about how I can apply it in my own instruction, in my work with faculty. But some of the ideas that I'd like to call out, given what I've been able to learn, are really thinking hard and intentionally about centering voices that might not typically be centered. So thinking about how my research relates to the research of people from traditionally marginalized backgrounds. How do I make sure that we're looking at the scholarship that informs our work of all sorts of folks, Black folks, people of color, people with different ability status. So I mean, physical ability is a real challenge. If you have varying physical abilities in the lab, how do you think about how to accommodate that in the lab, not just in a classroom? And that's where the research and teaching integration and cures can be a real opportunity for us to learn as researchers what we are able to do with our instruction in a more standard course. I also want to call out, in the book, we were very intentional about addressing diversity, equity, and inclusion as a standalone topic and integrated throughout the book. And we have called that out using icons throughout the book to point out strategies to make sure that students, all the students who are coming to your class, have an opportunity to engage in research regardless of their background. So hopefully that will be helpful to folks in thinking about that. And I think we have a lot more work to do.
Yeah, and the next question is somewhat related and may actually hit on what you were just talking about. But somebody asked, well, what does the education research say regarding the benefits of cures versus more conventional one-on-one research approaches for underrepresented populations? Are there statistically significant advantages, disadvantages, or no differences versus the one-on-one approach.
So Will, let me tag something onto Erin's last answer, and then that will bridge into that other question. So an example of one of the equity call-out boxes is that we make sure people are thinking about, if you're teaching this in a course that has some kind of gatekeeper to it, then why is that gatekeeper there, and who's going to have access to the course if that gatekeeping is there, and is it necessary? Can you make that a different type of access for that course? Also, how do you grade? We talk about grading on a curve versus not grading on a curve, and so on. The other thing I wanted to add is that in my most recent role at the University of Massachusetts, I have been working with non-STEM departments to think about cures, and this is a new direction for me as well. But it really speaks to the fact that the kind of research questions that can be explored through cures are, as limited only by your imagination to some extent. And you can certainly explore research questions that have importance to stakeholders and communities that maybe have not been traditionally represented in the kind of research that's driven solely by faculty members' need to be published and tenured. In a cure, there's a great deal more flexibility. It also means that in many cases, you can have a collaboration between somebody who's research focused and somebody whose contract is primarily for teaching, and you're very likely then to diversify the population of people who are involved in teaching the cures as well. So there are options there in terms of the types of questions that are open to you. Now, getting at that second question, I will say that the cure program called CASPI that I was involved with for many years while at Purdue had many partners from two-year colleges or community colleges, and they were not themselves research active, but became the collaborators and the teachers, and then ultimately published in the research that came out of those cures. But when we looked at the data of student performance, and this was not just student performance in terms of grades, but it was student reported gains in terms of different types of skills that they felt that they had at the beginning and at the end of the course, comparing cure-based courses to the equivalent non-cure-based course. And what we saw was a closing of the gaps between different minority groups when they were in a cure. And the biggest changes that we saw where those gaps were closed were in the two-year colleges that we studied. So in those populations where there's a much greater diversity of students than perhaps in the R1s that we were involved in. Erin, do you have some other thoughts on the data on that?
The only other thing that I would add is that there have been a couple of studies, including ones associated with the CPHAGES program. So Graham Hatfield, David Hanauer, Mark Graham, as well as research that I did when I was at UT Austin with the Freshman Research Initiative that used a technique called propensity score matching that allowed us to control very carefully for student level differences like incoming SAT scores or math and science course prep. And we were able to document, and the other study was able to document that participating in the cure versus other types of lab course experiences led to statistically significant and substantial, so large effect size gains in graduation from college and also graduation with a STEM degree. And that was the case regardless of student background. So the fact that these large programs involve thousands of students a year, and that you can see those rates going up significantly means that just many more students from backgrounds that would not typically participate in research get that opportunity.
Great, thank you. Next question is, does a cure need to persist for long-term for it to be feasible? I have an idea for a cure project, but I don't know that it could go on indefinitely like C-phages. So do you think that's still worthwhile?
Absolutely.
Yes.
Absolutely.
Yeah, it does not
wind up
persist.
as one project. Absolutely. And certain ideas then lead to new findings that students, make, and then you have new questions that you address, but absolutely.
C-phages is a very special type of example. I don't think it should be used as a standard comparator for anybody who's thinking about developing a cure.
Okay. Have you addressed funding the cures in your book and gaining support from your institute at the college level?
Yes, we did address that in the book. It's not a simple answer. There are a variety of strategies that one can use, and a variety of stakeholders. We talk a lot in the book about communication and about engaging stakeholders of various types, everything from those who are going to be actually involved in teaching the course with you to those who simply have to know that it's happening and give the thumbs up. So it is important, depending on how you want to scale it, to engage and inform the administration at various levels, and that will vary depending on your context. Funding is, we do address it. There are many avenues, and I'm sure that we only touched the surface on that with respect to possible ways that one can go. Erin, do you want to add anything to that?
Given the limited time, I think that's sufficient. Hopefully we provide sufficient advice.
Great. Well, let me move on. I think this one's really important, especially. Do you have examples for cures in the community colleges? So as research materials and resources are somewhat more limited than in a university setting.
Absolutely. So one big network I would call out is the Community College Undergraduate Research Initiative, which is led by Jim Hewlett at Finger Lakes Community College, and we point that out. Gabriela mentioned with CASP, partnerships between community colleges and research universities. And one of the kind of neat things, although it's hard to call COVID neat, that's happened with cures happening here at University of Georgia is that the fact that we're all working remotely has actually allowed us to engage students from other institutions that may not have the same research resources that we have here. And so we get an opportunity to work with students we wouldn't have usually be able to work with and potentially recruit them to grad school here. And then they get an opportunity to work with equipment and questions that they wouldn't have the capacity to at their own institutions. So.
Great, thank you. How do you objectively assess a cure experience?
Depends on what your goals are. So
yeah, I guess it's twofold, right? It's like how do you assess the students for one, and then also how do you assess whether it's successful or not for the course as a whole?
And it depends on what you mean by objectively, right? So with any educational project, you may want to, depending on if you're planning on publishing or trying to present these data for funding reasons, you may want to engage an external evaluator. External could be somebody at your own institution, but external to your project, somebody who has some experience in evaluating programs. And you'll begin by discussing your outcome goals with that person, both for the project itself and for individual students and you as a researcher. And those will become the basis of what you want to evaluate. You also may want to evaluate, as Will just mentioned, the student outcomes themselves. So there is a section in the book where we talk about how to assess student learning. So if the goal here is to figure out how to assign a grade to a student, that is a topic that we get into in the book. And you do have to think about grading very differently than you normally do, because hopefully there is not a known answer when you go into this thing. That's the whole idea, that you're doing research and it's about asking questions. It's about engaging in the process. It's about what you did today informing the decision you make about what you're going to do the next day in the laboratory and having those conversations. So you're really assessing student engagement in that process. And we do among those templates and resources that we have online and in the appendices, we have some grading rubrics there that we've provided that give, not that those are the only ways to do it, but they at least give you an example of the ways that you might look at student work and student engagement to give a grade for their participation in the course.
I would say that I'll add one thing. That's why I would say it depends on your goals. If you're trying to assess to publish, or if you're trying to assess to grade or give students feedback, thing that students struggle with is research is going to go wrong. And so they are going to experience failure, and they will perceive that failure as a failing grade rather than, okay, we have to think about this again or do it again or try something different. And so you're going to, as a CURE instructor, have to normalize the idea of failure being part of research and move them away from that way of thinking about it to the point that Gabriela was making about how is what we have done informing what you do next. And that's really what we're about, not about sort of the experiment failed or succeeded.
And in fact, I'd say that relationship to quote unquote failure is one of the really important lessons that CURES will help students learn, and part of how you develop that scientific identity. In fact, we talk about the fact that it's not really a failure, it's just a natural part of the iterative process of doing science. But many students have not even heard that language or thought about it that way. And so CURES provide a wonderful platform for now discussing what it means to build upon a result that isn't what you expected it to be.
Great. Do you think teaching faculty who don't have their own research lab can still author and carry out CURES?
Yes. In fact,
I know plenty of faculty who have.
Yeah. Right.
I think the only thing that I would encourage you to think about is how to really make sure that it's part of your teaching and that you're thinking about how the students can communicate those research findings to an outside stakeholder group. So who are they going to share their results with that will make it part of a larger research endeavor? And that can be done in a variety of ways, through collaboration, through, like Gabriela mentioned, database entries, a variety of things. So you just have to think about it a little differently. But that integration of research and teaching means you can be primarily a researcher or primarily a teacher and carry out a CURE.
And in fact, I'd say that this is very closely related to the question that came earlier about whether faculty in two-year colleges can do CURES. Absolutely, and it's really a matter of what you use as the starting point for the research question. And as Erin pointed out, what are you going to do with the information? How are you going to communicate it to a larger audience? But that can be anybody, anywhere. The CASB had a majority of its partners were two-year colleges, so it's absolutely possible.
Okay, thank you. I think we'll have one more, and then we're going to wrap this up. We're already a little bit past time here, so we'll finish with this. So, what do you think about using library research to implement a CURE? Is that even possible?
I tend to think of, yeah, go ahead. Do you want to?
I don't have a good answer, Erin, so if you do.
Yeah, so actually that's one thing that students sort of you have to expand their minds a little bit, because it may be the only research experience they've had before coming to your class is that library research. So certainly I've seen examples where folks are doing lit reviews and then finding the gap and proposing a potential research project. And I think that has educational value. I think the challenge is if they don't have a chance to then implement it, then you're only going to achieve particular outcomes for students. So I think you need to really think through what you want your students to gain from the experience. What are your learning goals for them? And is library research suitable for achieving those goals?
And I'd go back to what I was going to say was it really sort of depends on how you're defining library research. So when I mentioned that I'm working with non-STEM departments, in some cases, that is the way they do research. And so it is the way that knowledge is generated in that discipline. And so you would want to engage students in that practice. In your STEM discipline, whatever your STEM discipline might be, think about what is it that practitioners in that discipline do in terms of generating and working with knowledge in the discipline. In fact, how do you even think about knowledge in your discipline? And that's where you want to design the experience such that the student is placed in that role of the same as the research community for your discipline.
Great, thank you so much. All right, well, we are all out of time here, so we'll go ahead and wrap this up. Erin and Gabriela, thank you so much for your presentation today. I want to thank everybody who took the time to attend in person and ask these great questions. And I also want to thank everybody, projecting ourselves into the future here who may watch this at a future time on the recording. That's great as well. So thank you all for your time and attention, and we really appreciate it. Have a great day.
Thanks, Will.